There it is. Awesome. So we covered, well, Jordan covered higher order functions in JavaScript last Tuesday. How did you all find this lesson? Was it on a scale from 1 to 5? Was it challenging? Was it easy? Just toss some numbers out there.
It was easy,
Okay, cool.
pretty straightforward.
Okay.
Yeah, I mean the examples in these notes right here make it seem pretty easy to grasp. But then trying to move on to a more complicated problem, I was running into some issues. Like, you know, obviously it's easy to use these functions when you're just adding or multiplying, you know, a single array, but when you do more advanced stuff, it got a little tricky.
Right on. Was there any challenge in particular where it was more tricky than the rest?
Yeah, so for the hacker text, I tried to use these higher order functions.
Mhm.
I couldn't figure it out, so I just kind of made my own functions, and then I thought, okay, maybe I can like make my own higher order functions that I just call all three at once. So that's kind of what I did. I'm not sure if that's the right way to do it.
Let's walk through it. Would you like to?
So it's the third one from the bottom.
Okay.
So I actually submitted two. So I redid it last night. So it's it's that one right there.
Cool.
I wasn't sure how exactly to get, you know, like word line 34 to get all three functions to run. That's what I did. I tried to do it in the way that the notes from the lecture showed, where you kind of do the dot function name, but I couldn't get it to work.
All right, let's know it's the dot function name.
So it'll be like at the bottom. So like when he combined all three of them. Yep, right there, all together.
Okay. Did a filter, a map, and a reduce.
But like I didn't use any of those. I just made my own functions, so I didn't know if that's like how to, yeah.
Got it. Okay, cool. Let's take a look at this was JavaScript, right?
Yes.
Let's look at filter, and then let's look at map. And let's look at reduce. So one of the cool things about these built-in functions is how you can string them together in a sequence, just like in the example. If we look through this documentation, we can see that the filter method of array instances creates a shallow copy of a portion of a given array. And a shallow copy is a copy of an object whose properties share the same references, but are essentially a different object. So there are multiple ways that a function can manipulate the data that you're passing in. It could either create a shallow copy, or it could just flat out modify the values that you're passing in. In this case, for example, like if you were to pass in, if you were to call a function that mutates values, then the result is you call the function and the value, whatever variable you stored it in, will update or it will change. If it returns a shallow copy, then your original variable will not change. In this instance here, we're able to string these together because the copy that's returned falls into the data type of the array, and we are able to use these functions on that data type. So in your case, in your code, you created your own functions. The results that you're returning are a string. Yep, looks like in all these cases, it's a string. What was the message you were getting when you tried to string these together into one command?
I'm not sure I forget. But yeah, I guess I should step back. Like I thought it'd be easier to do it this way versus kind of the way we were taught, or at least for this example, because like there's the map and the filter and stuff. It seems like it worked best when you use it on an array and an array input and you want an array back. But for this example, for this challenge, it was you got a string and you want to return a string. So
Right. No, definitely. I mean, and I'm not trying to imply that like there's anything wrong with this example. If we get the result that we want, then that's perfectly fine. You've met the goal. There's always, especially with programming, there's like always more than one approach to the solution. And really it boils down to where you land in your career, how, I guess, finicky your team or superiors will be about the code that you create. A lot of times you'll really just have to be beholden to guidelines, syntaxes, formats that are, shared by the organization. But when it boils down to how you get there, the steps you take to get there, that's really all on you. If it works, it works. Let me share. I'm gonna switch gears here. I'm gonna share my terminal so we could start seeing some of this stuff in action. Any questions so far, by the way? Cool. This should be the right terminal. We're going to start a node session. And let's try some of this code. So if we were to take this first function here, I can't copy and paste today, apparently. Let's see. And how you have it down here is you have all, let's add all of these functions. So should now have all three of these functions defined. Cool. That's what I'm seeing now, how you take this. So we're defining a variable output header text, and we're letting it essentially be, it's essentially doing the exact same thing as that dot notation, right? We're nesting these different functions. So if we were to do a console log of hacker output text, we get the result that we want, text test example. And what's happening here is we're calling the function to remove. Well, actually, let's start here. At the very center of this, we have the string that we're passing in, test example, and we are passing that into the every other cap. What this is doing is it is alternating every character as a lowercase or uppercase character. And from there, we're passing in the result of that, which is another string to change letter E text, which is this function iterates through the string that's passed in, the text. And if a character is found to be E, then it is updated to, oh, interesting, what's happening here exactly. If the text at this index is E, then we want the result.
yeah, it was like change every letter E to the number 3. That was like part of the hacker text challenge.
But then what happened down here? Why don't we have the 3 in the final?
Oh yeah.
I think that it was only for lowercase e, if I understood
Oh, that's right.
the
Yes.
challenge correctly.
That is interesting. Okay, so it just happens to be that what we passed in has the e's in such a position that it's not going to allow for that. So let's change this to test example. I don't know. Let's try elephant. I don't know if that's going to work. It looks like it might not. Does it ignore spaces? If it ignores spaces, then this might work. Otherwise, it's probably not going to replace any of these e's with a 3. Does anyone want to guess whether it will or will not give us a 3?
I don't think it will. Now that I look at it and doing the math in my head,
Give it a shot.
because it does take, yeah, it takes spaces into account.
All right. So let's say let's add a colon in there. Ooh, it's ignoring the colon. What if we start with, but that's still going to give us. Oh, it's not updating. Identifier operator. Yeah, I see. Can anyone explain what's happening here?
Oh, it's
You used a let instead of a var, so you can't reinitialize it.
Exactly. So let's do a var instead. It's not letting me go up anymore. Interesting.
well, the A was removed this time. I think the E's are still.
All right, let's look through this code. So if we find an E in the text, then we take this string result, we increment it by 3. Otherwise, we take the value at this index and we add that to the result.
I think the e's are just in the exact wrong place. If you just add a bunch of e's at the end, it should work.
If we just add a bunch of e's to the end, it will work. Oh, and there's something that removes an A. Oh yeah, we have a remove letter A. Yes, exactly. Okay, I see. So let's this again. Nice. Code works.
Oh, I was worrying there for a minute.
Right on.
See, I guess the question is, what's the difference between how I called all 3 functions and then just the dot notation that was from last night's or 2 nights ago lecture?
There's really no different. At the end of the day, like the behavior is the same, right? But you're working with strings in one instance and arrays in the other instance. Also, Phil or Jesus, correct me if I'm wrong here, but does it have something to do with the methods in the example being built-in JavaScript methods?
I think so. Was he trying to use the chaining from JavaScript and Python?
Well, in the example, the chain that was happening in JavaScript, right, Michael?
Yes.
And instead, in the example, this was being done with built-in methods, built-in JavaScript methods. But then when he tried to do this with his own code, it didn't work. His own methods.
Yeah, I don't know. It's hard for me to tell.
Yeah, the tests don't require it to be a higher order function.
What was that?
The test doesn't require it to be like a built-in function or a higher order function,
Right.
right? The assignment was to do it in higher order functions though.
Yeah, let me go back to the challenge. This hacker text says to write a simple function that converts a string into hacker text for our purposes. You should use higher order functions. To start, you can write separate helper functions, but after you get it working like that, you try to do it as a one-liner.
Yeah, like I knew I was supposed to try to use the map and stuff. I couldn't figure it out. And then I wanted to just try it with my own functions. But yeah, that's something I'm gonna look into later though, try to do it with the map and stuff.
Cool. I think the key takeaway should be though, basically like how these higher order functions work, and as long as you comprehend that, then I think you met the objective of the assignment of the challenge. Awesome. Does anybody else want to demo their solution to hacker text? All right, let's see. I'm gonna dig through these solutions and Matt, do you want to walk us through yours?
Yeah, I can.
Cool.
Do you want me to share mine or?
Yes. Yes, please.
Do you want me to pull it up in VS Code or is this good?
Yeah, VS Code so we could see it in action. And yeah, just talk us through the code.
Okay, yeah, just 1 second. I'll pull it up. So this is actually my attempt at the using the higher order functions.
Mhm.
So I originally did it in 3 different functions, which I can actually show you here. I ended up changing it to try to get the higher order functions to work. But so this works, this one right here. This code does not work yet. I think that my issue was that I tried to use the map and filter functions on strings, and I didn't realize that until kind of later on, so I didn't get to rewriting it all the way. But I can just paste this in there and show you. So yeah, I just did it in these three different functions, and yeah, just put it all to lowercase first, then made a string and alternated putting it to uppercase.
Mhm.
Then I used replace all to replace I didn't know if it was E or lowercase e or supposed to be both. So I just did both lowercase and uppercase e and replaced it with 3. And then went through and removed all the lowercase e's. And these are the tests so I went into ChatGPT and asked it for some test cases to run it against. This one tripped me up at first because I wasn't accounting for lower and uppercase. And I think that was the only issue I ran into originally.
Awesome. Awesome work. Yeah, this looks really solid to me. Looks like it is fulfilling the objective of being a higher order function when we return new text. We are well, we're passing in text to hacker text, and that's just a basic string.
Yeah, and then when I tried to do it up here, I kind of got towards putting it all into different arrays, but
Mhm.
didn't get all the way there.
Okay. Does anyone have any questions about Matt's code? Cool. Looks good to me. Thanks, Matt. All right, let's go to the next challenge. It is Armstrong numbers. Who would like to volunteer?
I can show mine if no one wants to. I did it in Python and JavaScript, so which one would you want to see, I guess?
Let's do JavaScript because we'll be covering Python today.
Okay. Oh, wait. Oops. Um, Again, I didn't use the higher order functions. I'm not sure if you even could for this one. Actually, I don't think you could now that I think about it. But so one of the first things is like, how do you make this more scalable and reusable later? So I put my comments for my Python one. I just didn't copy over. But basically how I did it was I have a start and a stop. So that way I can just, whatever range I want to check, I can just change it here. So then I made an empty list to hold the numbers that satisfy this. And then I go through a for loop for each number. I found the easiest way is just create another list or array to hold the current digit. So like if the digit is 2 digits or 3 digits, then I split it into this. So that way I can look at each digit one by one.
Mhm.
Made a variable to hold the calculation. I had to convert the number to a string. I'm just doing this based on what I know of Python, where it's like you can't really like to mess around with digits. There might be an easier way in JavaScript, but I just converted it to a string. That way I could add it to my array. And then in that array, I'm going to do the calculations, which is the digit raise it to the power of the length of this array, which tells me how many digits are in the original number. Added to this total after calc, and then compared to the number. And if it's equal, add it to the output array. So, oh wait, hold on. Yeah, so that's I got work on writing tests. I'm pretty bad at doing the test files for these challenges. But yeah, that's kind of where I got.
It's all good. You will get a lot of practice writing tests, and if you recognize that's opportunity for improvement, then you're already on the right path. I'm double checking this. This looks good to me. Does this not look good to anybody here? Awesome. Yeah, it looks solid. I think that's that output is correct. Right on. All right. Great work. Next one is some pairs. Who would like to volunteer for some pairs? Let's go with who is fit code X?
That's me.
Right on. Awesome. You want to walk us through your solution, Ricardo?
Yes, let me just pull it up real quick.
Sure.
All right, so I created a function with array and a target, and I created a variable with a empty array.
Mhm.
Created two for loops. The first loop, it starts at 0 and goes through the length, and the second one, it starts at 1. After that, create an if statement. If array I, so first one and the second one adding together equals the target number, it gets pushed into the pairs. And in the end, if the pairs length is greater than 0, it's gonna output the pairs. If it doesn't, it ends up with the output of unable to find pairs. And I'll test it out. Show you. What did I do?
You're not in the right folder to execute it.
Oh,
Do an LS. Yeah, you did code. Yeah, there you go.
There you go.
Nice. All right, let's talk us through the solution.
So the I created a variable named pairs, and with the value of an empty array. I created 2 for loops. The first one starting at 0, and the second one starting at 1. So it's gonna be one ahead of the first one.
Can we
After
slow? Why is that necessary?
So because it's trying to find the pairs that equals into 9. Well, that equal 9. That's how I did it. Well, that's why I took in the challenge. And afterwards I ended up creating an if statement. So as it's going through every value in the array, it's adding them together. And if it equals the target, it's going to push it into this variable.
Mhm.
And afterwards, if there's 2 values in the variable, it's going to output the pairs. If there isn't, it's going to show unable to find pairs.
Okay. And can we see the tests again? So in the first case, you're passing in numbers 1 through 5, and you're looking for 9. And so as it's iterating through this, I is equal to, for example, 1. When I is equal to 1, j will be equal to 2, right?
Yes.
Okay, and that's why you have it adding. And then we saw that the solution was 4 and 5, which is correct. And in the second example, we have 2 and 5, 3 and 4. Can we write another test where we are looking for an even number?
An even number.
Yes. Yeah, let's just copy like either 3 or 4, line 3 or 4. And let's try looking for 6. Awesome. In the array, can you add a 3 at the very end? Nice. Awesome. Looks good to me. It works. Awesome work, Ricardo. Any questions from anyone? Cool. I like that you wrote out the test. I like that you also added your pseudocode. That's great. Awesome work, everyone. Let's shift gears over to higher order functions in Python. And today, Philip will walk everyone through that. So take it away, Phil.
All right, sounds good. Let me get my screen set up. All right, is my VS Code showing? And so a lot of today's lesson is going to be pretty interactive. I'm going to want you guys to either help code along or help with some questions. But we're going to start out with some pretty simple stuff familiar to like what we started with yesterday. We're still covering higher order functions and map, filter, and reduce. But we are going to touch on probably some more complex examples just to make it a little bit easier to understand. I know it's a little tough if all of the examples are as easy as this function. But we're going to start with up at the top. Has anybody heard of first class functions or the term? Is anyone familiar with it? Okay. It's not super important. It's just stuff to know about and good stuff to think about. But in JavaScript and Python, functions are first class citizens. And what it means to be a first-class citizen is that you can treat this thing just like any other variable or argument. So you can assign things to it. It can be returned. So those are like some key takeaways. So here I've got a simple function, and how are we used to calling a function like this? If I want to use this square it function and square, I don't know, 5 or something, what do I do to run that?
You write the function call and put 5 in the parentheses.
Okay, so we'd have something like that, right? And this is typically, how we've been, sorry, Zoom's going a little crazy on me. This is typically how we run our functions, right? And so I've been really lazy. I named my file main. So I'm just gonna run python main.py and check. And sure enough, we have our function here running. So what happens if we run it like this? Does anybody know? So this is an example of that right now we have a variable called square, and we're initializing it to this function square it. But if you notice, there's no parentheses here. You've got to include parentheses when you're telling a function to execute, but we're not asking it to execute here. We're just saying squared is now equal to this function. So if I print this, it's going to look a little weird. But what we end up getting is just a memory address. And all you need to know is this has something to do with where this function is stored in memory. But that we'll get to that later. But an interesting thing, so if I take this function, we can square and run 5 like we did earlier. And now instead of a memory address, we're going to get our number back. And so like this, the reason I brought up, first class functions and what's important about higher order functions has a lot less to do with map, filter, and reduce than you would think. There's a lot of other things going on behind the scenes that have to that help you understand how Python works and what's going on when you're calling functions. So like, for example, we're not going to get into it today, but if a higher order function is a function that can accept or return a function, then like the notion of recursion, I can have a function that calls itself or something. But anyways, I just wanted to show that. Let's see what else we got. All right, so and this is basically a custom higher order function. Here we have we can have the same function that we called, and we can call that function inside of it with the value. And then, so what do we think 3 squared would give us? That looks like 3 to the 4th power to me. I haven't done math in a while, but and I don't want to do it publicly, so I'm just going to assume that's right. And so you can look, this function here is essentially the same thing we just did there. We have our function that's stored in our variable, and we're calling it twice, but we could also return it in this function and call it twice. And you can see this is obviously a little bit more readable. And I already see, I think I got some print statements that I'm forgetting. This is why a lot of the lectures are not done in this format, because it gets a little annoying to figure out where you're at. Okay, so that brings us to, I mentioned it earlier, higher order functions. So we're just talking about a function that accepts or returns a function. what we have here, what does this look like if without me describing anything to you guys? Is this Python's version of map, or is that just some function?
That just looks like your custom function. I don't think it looks like anything built in to Python.
Yep, you're absolutely right. You're gonna see in some of these things, you know, for thing in my list, some of these things are poorly named on purpose. But also sometimes when they're poorly named, nobody is gonna think that thing is a reserved word in Python. So I wouldn't look at these examples. I'll post this later for anybody that wants to go through some of these examples. But as you're going through it, you know, look more towards the examples at the end of the lesson. A lot of this is just to show you how it's working and what's possible. So, you know, we did this in the lesson yesterday for JavaScript, but here is a myMap function. So we defined a function that takes some argument called my function, which I'll assume that's going to be a function, and then another argument called my list. And those are the two things that you would need if you were going to use, you know, .map in JavaScript. So you basically, I'm just trying to show you often are not going to use map like this. It's helpful for you to see that you have a function that's taking some function that you're defining, and then you're passing it this thing that you want to essentially perform actions on every element of. So I'm not even going to run this. We're going to skip past some of these more boring examples, but well, you know what? I'll go over. Let's go to the docs real quick. Does everyone see my browser? All right. So all I did to get here was I Google searched Python docs and Googled map, and some stuff came up and I got to it. But it's good. I'm not going to go through all of these. But if you look, map takes a function, an iterable, and iterables. And something to consider or to like pay attention to is it returns an iterator. And the reason I'm jumping over to show you that stuff is like there's a lot of terminology that you're going to commonly see in the documentation, and becoming familiar with it is going to be what helps you look up things later. Because otherwise, if you never look up what those do, then whenever you find out something returns an iterator, that's not going to mean anything to you. So let's go to the map version. So what we have is, this is map from Python, the built-in function, hence my naming for the variable. But if you'll notice, I have this list before it. So if we run this function, let me see, do I have more print statements? All right, sorry, I'm trying to keep it relatively clean, but you can see we just mapped this list. We took 1, 2, 3, 4, 5, and then ran our function. But if I were to try and use map without, without it being in a list, I'm going to get, again, some kind of memory address for where this thing's at. We'll probably talk at some other time more about iterables and stuff, but it's a little bit too in depth to bring into this lecture. But to keep it simple, you can for now just think that an iterable requires an iterable. Oh man, I'm messing up my terms now. It requires an iterator. So if you have an iterator and it's not in an iterable, like a list, for example, then you won't be able to get any values out of it. Okay, so what else do we got? Put list for Python.
So anytime you use a map in Python, you have to assign it to a list.
So, sorry, can you repeat the question?
So you have to tell it to go to a list. So you're putting the map within the built-in list function.
Yeah, well,
in order for the
just like our
output to
custom
be
function,
Mhm.
the built-in map needs a function from the docs. So to pull it back up, but you need to pass map a function, which will be what is going to act on each element. And then an iterable, a list is an example of an iterable. There are other iterables besides lists. But that's what I was saying is the discussion for what an iterable and an iterator is actually a more in-depth topic than it would seem. But you know, essentially there are some custom methods that are available, and to be an iterator, you need to have some custom methods available, and to be an iterable, sorry, I'm getting tongue twisted. To be an iterator, you also need specific special methods built in. But that all has to do with stuff that's happening kind of under the hood in Python, though. So that's why it's not very important for what we're doing right now. So I'm going to go ahead and get to filter. So I think what threw me off as I was looking, we're still kind of skipping over how a lot of this stuff is, you're going to see it in the wild in Python. And we're getting there. So let's see. If we want to try and filter this, I already got a function here. We have, you know, less than 10. Would everybody agree? You know, this looks like it's going to return true if it's less than 10 or false if it's not, if you were to pass a number through. I'll take that as a yes. But so similar to using map, it's a very similar setup. You've got a function that you need to pass and some iterable that you need to have. Our iterable in this case is our input list. And just like before, you're going to need this thing inside of a list if you're going to be able to see the values in it. Sorry, the zoom bar is like completely blocking my terminal. All right, got it. So now if we look at this is our list of numbers. And it looks like our function worked correctly. The only numbers I see out of this list that are less than 10 are the numbers it gave back to me. And we left this. All right. So another way that we could write the same list, so this is where we're getting into something we haven't seen. But a common way that you're going to see people filter in Python will be a list comprehension. So we can actually comment this. And so I could do something similar where here I have nums less than 10. And now instead of a function, I've got, you know, what looks pretty similar to a for loop and an expression. And that's like really the best way I can break this down is we're looping through this input list, right? And num is going to be each element as we're going through. And we have num out here because we're going to use it in this expression. And that's where we're saying if num is less than 10. So that's going to evaluate on each element to true or false, and filter is going to grab everything that is returned that is true, and then anything that's false is going to be ignored. And so if I run this, we should see the same list, right? But you'll notice a lot of things there. Instead of having to cast this thing in a list, you still do need to put this thing inside of a list, because it's going to return an iterator. And so if you try to run this, without it, I honestly, I think it will just error out. But the other, common way that you'll see stuff is what I have here, with a lambda function. So this, we're going to do the same thing again, except this is just our example of using a lambda function. Has anybody seen this in Python? Or I guess I really should say, has everybody seen this? Because I feel like most people probably, I know I didn't at this point in the course when I was going through. So if you're familiar with anonymous functions in JavaScript, like a fat arrow function, that would be like the closest relation, but it's the same idea. In JavaScript, they often call them callback functions, but the idea is you've got this function, you don't really care about its name, you don't want to call it, it's going to return on its own, you just want to tell it what to do and be done with it. And so here, when we say lambda, it's waiting for our expression next, so we can pass it arguments up until the colon, and then after the colon is where our expression is. So here we're saying, hey, I've got this argument called number or num, and if num is less than 10, is what I want to use as the expression, because basically this lambda right here is the same less than 10 function that we have here. That's just how it's written. Does that make sense? Have I lost anybody? Okay.
So it's just for conditions.
No, just like a fat arrow function, you can pass it an expression and it returns on its own, but you can. Yeah, sorry, did I answer that correctly, or maybe I misunderstood the question?
Yeah, no, I'm tracking.
Okay. So a reason why you will see them for high order functions is like where the MDN documents will provide a callback is what they'll call it for a function. It's like the same idea here is when you're reading this code, if you write something like less than 10 as a function, I've got to go find less than 10 now. I need to go see what less than 10 does, because I don't know what you're doing to every element. But if you write a lambda function, I can see the expression, so I have some idea of what what's happening in there. But that's just some food for thought. Let's see. All right, reduce. This was one that I struggled with, like figuring out when I was going through the cohorts. I tried to come up with a good example, because I was always, when I solved these same problems, I was like, I can't find a good reason why I would want to use reduce for just about anything. But it's I wish I could say I found a better example. We've got a bunch of boring stuff still, but I do have one interesting one. So who remembers what reduce did in JavaScript? Can anybody tell me?
It adds up all elements in an array and returns a total, so like an integer or whatever it is, a string.
Right. So, and I like, what helps me remember is I always think like it reduces down to a single element. but the default behavior is adding. So if we take this boring list and then this again, you're not typically going to see functions like this. This is why I chose some bad names, but I wrote a function here that is basically our custom function for reduce. So we're passing it a function that has an accumulator and current value, and we're getting back our list. So that looks pretty correct to me for adding up 1 through 5. I know I missed another print statement again. All right. One thing I kind of skipped over, if you notice here, I've got an import, and that's because when you do reduce in Python, you need a library within it to access reduce. Now, there's other things inside this this library you can look up, but Python has a lot of libraries that are helpful for solving problems or more efficient algorithms and stuff like that. So, for example, functools, has some caching. So you could do lookups for, recursive calls potentially quicker or something like that. But I'll leave that for you guys to explore on your own time. The getting back to reduce, one like very common reason that I will almost never use it in Python as far as with addition or with its default values, is I'm not sure if anybody, here I'll do print list, and then I can do something like this. Ooh. I did something to reduce. I think it's what line is that? 240. Man. Sorry, I'm definitely not expecting this to happen. Do you perhaps see what I'm doing wrong, Julius? I'm kind of lost with the traceback. 276.
Let's see. So let's go a bit. You're passing into
Oh, I see. I think I think the issue is that I have other functions that are using some or trying to use some, and by changing it from a list, I'm causing problems with the current total. So let's try not changing it. All right. I'm not crazy. I'm just tired. All right. So why did I show you guys that? The sum is, would you guys agree this is a lot easier than passing things into reduce? And then also if you're reading that, it's pretty obvious that somebody just summed something right there. So as far as like a good use case for reduce, it's just you probably will want to do some other operation besides adding. Otherwise, it would just make a lot more sense and be a lot more readable to use something like sum. We've got some examples of reducing by subtracting, and also I'm just going to skip ahead again. Sorry. But I know that the subtraction example is kind of boring and straightforward. So we're going to go to, I've got a prefix example. And this is because I noticed while I was doing the lecture, but it's the idea of an accumulator. You hear the term for JavaScript and for Python when using reduce. Like, what would you guys say an accumulator is?
The total value.
Okay, was close. What
Accumulator something that increments or you add to it while you go up the index.
Okay. Yeah, and you guys are both like pretty close, but a good way to think of it is you're right, it is accumulating something, but what's useful to us is it is a cumulative sum, right? So your accumulator is not what you get back from reduce, but what reduce has while it's calculating that is from the accumulator, and the accumulator is all of the sums. So if we're at 1, the sum is 1, but then when we move to index 1 and we're at 2, the value is going to be 3 inside of the accumulator. And so I just wanted to bring some of that up. Has anybody heard of like prefix suffix algorithm? We're not going to go into that because it's I feel like some people's heads probably already heard enough, but it's a very useful algorithm. So your accumulator is basically going to calculate a prefix sum, and your prefix sum is that running total of the sum. And why that's important, in short, is that if you have a cumulative sum, you can calculate a sum for any element inside of a list or inside of an array. So it likely means that if you're able to get a cumulative sum of something, then your next loop can keep the problem at an efficient runtime, essentially. But so we're going to go into that a little bit. This is how you calculate a prefix sum, right? From scratch is so we have a list here as an example, and then this line 263. What does this look like?
You just assign the variable prefix to the first index in the list above it.
Okay, what's in the first index?
So it's the number 1. So prefix now equals 1.
Does it equal 1 or does it equal a list of 1?
Oh, sorry, I couldn't see that. So yeah.
Yeah, no, it wasn't meant to be a trick question, but at the same time, it won't work if you don't do that, right? Because we talked about some of that stuff earlier, but okay, so what's happening? Somebody else, tell me what's going on from 265 to 266. No one? Wait, I know we went over loops. This is not the part that you guys shouldn't know. Okay, so what we have is we've got a range, right? And we're starting at 1, and we've got a length of this prefix list. So we're just using a range function here. Why are we starting at 1?
Because prefix is equal to the 0th index.
Right. And so we already have 0 in there, essentially. So you can write this code, many different ways, because you essentially just need to be able to get a list of the running total. But when we're appending here, so prefix I is going to start at 1, or sorry, index 1, right? Because 1 is already in there. Now, what is prefix -1?
That's the last element in the list. So that'd be 2. I think that's what was throwing me off. It was like, if you're just going to constantly add the last index, I wasn't sure what it was going to do to
Yeah. No, it's a little tricky at first, but yeah, so it's the last element of this list, right? So when we start, that list has 1 in it, and then we're running prefix I is 4 plus 1, we're going to get 5 for our second value. And then we're going to keep repeating this where this is the sum that we need. This is what we're adding to, and we're continuing our way through till the end, right? But the power of this is, you know, if you wanted to know the sum of these elements or something along those lines, you can calculate that because you know the running sums. There's a portion of the array that this sum is equal to, and this sum is equal to, and if you take them away, you're left with what you have. But I don't want to get, you know, too far into the prefix sum. I just wanted to expose it a little bit. So here is just the accumulate. So again, this is the same thing that we imported from earlier. And I should mention too, I feel like most of you know, but you know, you typically would import at the top of your file up here. You don't necessarily have to, obviously, because my code's been running fine. But you're just going to run into issues that you shouldn't if you just put them at the top. If you don't believe me, just put them at the bottom. Sorry for all the scrolling, guys. Let's see. All right, so we're trying to get back to accumulate. All right, I lost it because I was looking for the import. So we're just going to print this, show what is this thing. And so there's a, you know, more visual example that's a lot faster than what I just did. So, you know, that's another takeaway is if you don't want to remember how to calculate a prefix sum, you know, nothing's stopping you from importing accumulator. And then you just say, hey, I have this list, use accumulate and, you know, give me the values. All right, almost done. Sorry for the long lecture, guys, but I got one more example where we use reduce with strings. So that's what I was looking for as far as an example where you would use like the initializer. And so there's other ways to do this besides reduce again. So this would just be if it was convenient for you to do it this way. But here we have sample strings, which is a list of strings. And then we've got char count and our reduce. And then what is our lambda function doing? What's the expression I got there?
So it looks like the first variable will add the length of the second variable. So then the second variable is each string in the sample string. So you're basically just, is it kind of like the same thing? You're adding the length.
Well,
let's see
here, let's look at the simple example again. So I just remember I had this typed out. Let me just move this. So when we call reduce by default and we're going through this list, it looks something like this. Like by default, it's going to grab this first thing in the list and the second thing in the list because it needs to start doing its calculations to reduce. And then it'll go on for +3, +4, +5. The reason you provide an initializer is if you're going to start from a different point, essentially. And where that could be useful is if you're going to use reduce with a string, the reason we're using length is you need to be able to get a number somehow. We're trying to calculate something, and we typically don't want to calculate, with operators and strings. I might have just blanked out. What were we talking about?
So I think I get it now. So like if the list one, the initializer is okay. So like basically adding the length of each of those strings in the list, starting with the 0 string, which is the I1.
Close. So yeah, when you're starting at 0, you're going to only be looking at this first string because that's going to be the current value, because by starting at 0 or providing somewhere to start from, we're telling it we have a different argument essentially. So 0 is taking place of 1 here, and then our index 0 is taking place of where 2 is, and it's for the case of doing a string, because if we're going to add the lengths of the string, we can't start somewhere else than 0. Otherwise, we're changing lengths somewhere, if that makes sense. But what this ends up reducing down to, so we got the length of a string, right? And that's just some number. And so we're going to basically go through this string and get a number, and then add it to the next string and get a number, and then get and all the way until we get a character count. And 131's the character count. The other one is a print statement I left somewhere. Okay. Sorry, I lost my place, unfortunately.
I think you were down.
Yep, reduce. Yep. Okay. Just run this again and see if I got that. Okay. And then we'll just to show, if I try to run this, it's immediately gonna try and complain, and it's saying, string not int to string. So it's given us some reference there that we've made a mistake.
What happens if you put 1 instead of 0? Can I just see the output of that?
Yeah.
So it's 131 before.
Yeah, and so then it would be 132, and so that's what I was saying is, like, if you were trying to count the characters, you're gonna mess up the count if you start somewhere else. But
I get it.
Awesome.
If you remove the 1 at the end of that and then change it to ACC plus val, would it just concatenate all that together?
Say that one more time. If I remove what?
If you remove the 1 after sample strings,
Okay.
and then remove length val and just make it ACC plus val, would that just concatenate it?
Let's see. Looks like it. I had a exercise to do later. I'll probably just put this up as a bonus problem to solve tonight. Does anyone got any questions? I feel like I went a little overkill on the lecture. So if anybody is lost, just let me know and I'll try and clear up whatever I can. All right.
Oh, I was going to say that I didn't quite understand that the very last output with the 131, 132. I'm still trying to wrap my head around that one.
Okay. No problem. So that was, let's see. Okay, so 131 is what it changes at normally. And remember, when we're adding in here, we're using this value. So 0 is what we're starting at. So if I change this to 20, we started at 20, so we would expect this to be 151. And it's literally, it's producing the same thing, but we told it to start somewhere different. Does that clear up any of it?
So the first portion is essentially the sum of all of the characters in the sample strings array, and then that last argument would be just an additional number that we want to add on to that sum. Is that correct?
I'm not sure if I understand the
Yeah.
the question, but
Yeah.
go ahead.
Oh no, it was just my interpretation, and I'm not sure if this is correct, but so basically what this is doing is summing the characters of all of the strings that are in the sample strings list, and then to that number, that sum, it's going to add 20, and that is going to be, in the end, the result would be 151. Is that correct?
It's close. So remember that this this initializer is an optional third argument, but the initializer should help you remember it's where you're starting at. So it counted to 131, but it started at 20.
Okay.
Yeah.
Got it now. Thank you so much.
No problem. Any
So
other
is
questions?
Is that 20 or just the third argument? Is that like the first value of the accumulator? Like when the expression first evaluates?
Yeah, it is the like, and then if you were to like print out the accumulator, you would see your initial number and then your cumulative sums for the list. So your accumulator would actually be one item longer than your values. But you know, every other time you use reduce, you're getting lists that are the same size as far as your accumulator is concerned. And then of course it gets reduced to 1.
And then I just had a quick question just to confirm. So with Lambda functions, so I got the syntax down right. So after Lambda, you put in kind of like what would be the inputs for a function, and then the colon is what you're going to do to each input in that function, right?
You could think of like how we have you know, some function up here. We can do like def some function. You can think of, you know, being up to the colon as being up to the colon there as well, right? And so once you've already given Python a colon, now it's waiting for an expression somewhere. And so then you'll have, you know, return something like that for your return. But when you use, an anonymous function in JavaScript or a Lambda function in Python, you don't have to, it returns on its own. So it's implicit, or it's implied that it's going to return whatever the expression is. So does that help at all? It's like right here, you've got your.
Because I was just like, the thing that threw me off is then I'm like trying to, so then after the
But
line 333, then so you got the colon and what you're doing, the expression, then the comma, then sample strings. That's just what you're throwing. Okay, so that's what you're throwing into the Lambda function. Okay.
right, and then like if this was, some other function, you could do something like this, and that would still be a valid Lambda function, or what, it's going to take this argument and this argument, and if they're not equal, it's going to say false.
Okay.
But I do think it helps. I struggled with it for a while, trying to figure out what was going on in this middle portion. So hopefully that helps. Any others? Awesome. I'll be happy to give it back to Julius.
Right on. Awesome, Phil. Thank you for that lesson and all the concepts that you threw at everyone's way. Great examples. I hope all of that was very helpful at giving more insight into higher order functions. Now we're going to break into our breakout rooms. And actually, before we do that, take a break because we've been here since 5:30. Take about a 15-minute break. When you get back, I'll have breakout rooms open for all of you. Cool. See you in a bit.